Welcome to the Exam Technique series on the Science Revision Coach channel. This series is designed to support you with your exam technique so that you can show off the science knowledge and skills you have been able to recall from the Revised Science with Me series. This video is about how to answer some quantitative chemistry questions. Before we can attempt past paper exam questions on this topic, you first need to be aware of how to approach exam questions to ensure that you use the time allocated efficiently. Step 1. It sounds obvious, but read the blurb of the exam question. This sets the scene of the question and gives you an opportunity to think about whether you are confident to answer the question straight away or whether you will need to come back to it. If you are confident, move on to step 2. If you are not, this is the time that you need to move on to the next question and follow the steps above. Step 2. Deep read the blurb, data and any diagrams associated with the question. Do you understand what the question is asking you? Have you noticed any patterns or anomalies? Highlight or underline any information of note and annotate as appropriate any of the key information you have noticed. Step 3. Read the actual question. The question would have a command word in it, and if you're not familiar with the types of command words used in GCSE science exams, you can see the link on the sciencerevisioncoach.org website on the students page for a comprehensive list of AQA command words. Step 4. Using your annotations and your knowledge and understanding, begin to answer the question. Remember, you do not have to write in detailed essays for extended response type questions. You can write using clear bullet points, labeled diagrams, tables, and flowcharts. It's advisable to use pencil and ruler to plot and draw graphs. Use a ruler for accurate measuring of data on graphs. Use black pen to write your responses using clear scientific language and legible handwriting, and show all your mathematical working out. Lastly, don't forget that answers from previous parts of the question may be needed in later parts of the question. And just one final thing about numeracy tasks. Remember, check for any conversions of units, check in case you need to rearrange equation, those doing higher tier, and make sure that you write the correct units and standard form or significant figures as requested. Before we start the first question, this video is a follow-up to the quantitative chemistry exam technique videos part 1 and 2. Have a look at those videos if you haven't already, and subscribe, like, and share this channel to help it grow. The first question is 6 marks in total, so just over 6 minutes. I have to decide whether I have the knowledge to answer it immediately or move on to the next question and return to it later. As I study the blurb, I can see that it is about relative formula math, and I will annotate the important things as I read them. I have the knowledge to answer the question, so I go ahead. It says the information on the data sheet will be helpful in answering this question. Now, I know the mass numbers of most of the common elements used in these types of questions just because of my own personal retrieval practice when I teach this every year. So part A, question 1, says calculate the formula mass of the compound iron 3 oxide, and they've given me the formula Fe2O3. Now I know the mass number for iron is 56, but that will be on the data sheet that you'd be given in the exam, which is basically the periodic table. And there are 3 oxygen atoms, each of a mass of 16. So that's 56 plus 56, add 16 plus 16 plus 16, or 56 times 2 plus 16 times 3. And that gives me an answer of 160. And that's what I show on my working out. For part B, it then says calculate the mass of iron produced when 32 grams of iron 3 oxide is completely reduced by aluminium. And the reaction is shown in the symbol equation. So this is a link to part A. So my answer to part A is actually going to help me with part B. Now, just whenever I do quantitative chemistry questions, first step I always do is I check that the equation is balanced. One of the typical part A's of these types of questions is to balance the equation or calculate a formula mass. So we did the calculating the formula mass, but it could have easily been balance the equation. Now I'm just going to double check that it's balanced, and I can see that it is. So the next step is to actually put down the masses that I've been given and the masses that I'm trying to find out. So underneath the balanced equation, I'm going to write 32 grams underneath iron oxide, and then I'm going to put a question mark underneath the iron, because that's what I'm asked to find out. Now, step 3, I then write down the formula mass of the known mass and the unknown mass. So the mass that I've been given and the mass that I've been asked to find out. So I know that the formula mass for iron 3 oxide is 160. So I write that down. And I know that the formula mass for iron is 56. So again, I write that down. And then step 4, I need to find the moles. N equals mass over formula mass. So I'll have to use that equation. Now, if you look at the way I've written steps 2 and 3, that's basically the equation. I just need to put a divide line in between the numerator and the denominator, if you like. And I have seen that I can calculate the number of moles of iron 3 oxide as 0.2 moles. Now, I can't do that with iron because I don't have the mass, and it's the mass that I'm trying to find out. But what I can then do is use the balanced equation to work out what the number of moles would be based on ratios. So I look at the ratio of molecules of iron 3 oxide to iron, and I can see that for every 1 molecule of iron 3 oxide, 2 molecules, or 2 atoms, I should say, of iron are produced in that reaction. So it's a 1 to 2 ratio. So if I have 0.2 moles of iron 3 oxide, I should have 0.2 times 2 moles of iron produced. So that is going to be 0.4 moles. So I've worked out the number of moles of iron. Now I've got the number of moles of iron. I've got the formula mass of iron, or the atomic mass, if you like, of iron in this case, and therefore I can just rearrange the moles equation, so 56 times 0.4 to get 22.4 grams. So I now know that for 32 grams of iron 3 oxide reacting with aluminium, I will get 0.4 moles, 22.4 grams of iron produced. Okay, so hopefully you can see that for the 6 marks so far, we have not used the 6 minutes of time that was allocated for this question. Despite taking my time to read and annotate the question and write the answers in this time, you can see that it has been possible to do within the time provided. Now let's look at the examiner's report. A majority of candidates produced a correct answer to Part A, but Part B was correctly answered only by a minority. Many candidates gained some credit for having correctly indicated, by implication amongst other information, that 160 units of iron oxide produce 112 units of iron. Far fewer were able to pull out this information from the other figures they had also unnecessarily calculated, and or to scale the figures appropriately. So it's the ratios which really mess people up. Okay, question 2. Now this is a 4-minute question, so 4 minutes allocated. The formula for the chemical compound magnesium sulfate is MgSO4. Calculate the relative formula mass, MR, of this compound. Show your working. Now, in order for me to do that, I need the data sheet, and obviously I have the data in my head because I know that magnesium has a mass number of 24, sulfur 32, and oxygen 16. So I'm going to write 24 plus 32 plus open bracket 16 times 24 and 16 times 4, close bracket, and that is a sum of 120. So that is the formula mass of magnesium sulfate. The next part of the question says, part B, magnesium sulfate can be made from magnesium and dilute sulfuric acid. Now I could start writing the equation, thinking of my reactions with acids, but they've said this is the equation for the reaction and they've given me the equation. I'm just going to double check that it's balanced because that's always my first step. Just double check it's balanced, and I can see that it is. And it says calculate the mass of magnesium sulfate that would be obtained from 4 grams of magnesium. So again, just like as before, step 1 was balancing the equation or checking that it's balanced. Step 2 is write down the known and unknown masses. So underneath magnesium, I'm going to write 4 grams. Underneath magnesium sulfate, I'm going to write question mark because that's what they want me to find the mass of. Step 3, I'm going to write down the formula mass for the known and unknown. So for magnesium, it's going to be the atomic mass, which would be 24. And for magnesium sulfate, it's 120. I'm then going to, for step 4, calculate the number of moles. So it's going to be 4 grams divided by 24, because that's the known. And I get 0.17 moles of magnesium. Now I look at the ratio between the magnesium and the magnesium sulfate, and it's a 1-to-1 ratio. So 1 mole of magnesium reacts to form 1 mole of magnesium sulfate. So if I've got 0.17 moles of magnesium, I will also have 0.17 moles of magnesium sulfate. So I have the moles of magnesium sulfate, I have the formula mass of magnesium sulfate. I can now work out the mass in grams, which would be the moles times the formula mass. So 0.17 times 120, which will give me 20 grams. Now, again, hopefully you can see that for that 4 marks, I have been able to use the time effectively under 4 minutes. And this is despite taking my time, reading through, showing you how I've thought and worked out the questions. So I hope you can pause now and reflect on how I've done this and shown all my working out in terms of how I work out reacting mass type questions. Now, unfortunately, there is no examiner's report for this particular question, but it would, I suspect, have a similar observation in that students struggle with the ratios. And I know that from my teaching experience, that's where I normally see students struggle. They get everything up to step 3. And then step 4, that's where the confusion lies. So make sure you've understood those. And if necessary, I might just do a separate video, a revise with me on how to do the reacting masses type questions in terms of revision. So how you could remember the steps. So thank you for sticking around to go through some exam technique practice questions. Visit the sciencerevisioncoach.org website for links to useful resources. And if you have not already, please subscribe, press the like button and share this video.